Hello, my name is Ashton Dunn, and today I'll be informing you about why we have alternating current in our houses. The speech may not be the most entertaining speech, but it is super important as it can save money and lives. It all started with two brilliant electrical engineers, Thomas Edison and Nikola Tesla. Nikola Tesla was a huge advocate for alternating current and wireless energy. Tesla spent most of his time conducting a variety of experiments. Often, these experiments involved a mechanical oscillator or generator. Mechanical oscillators use magnets to shoot a magnet back and forth until it hits the equilibrium point and is stopped by the other magnets. Through Tesla's experiment with mechanical oscillators and generators, he developed the first alternating current motor in 1888. According to Dr. Sebastian Barish from Milwaukee School of Engineering, this breakthrough is what inspired Nikola Tesla to continue his career in electrical engineering. The current war, the war between alternating current and direct current, has been going on for about 2 years now. In 1889, Thomas Edison Company invented direct current power lines. Direct current power lines were the first way to send high voltage electrical current across long distances. These power lines had many flaws. As explained by Mehdi Sadegard, a Canadian electrical engineer, direct current constantly runs current through the wire transmission lines, which causes them to overheat. The only way to combat this is by making the wires thicker, which costs more money and resources. The large amount of current also results in voltage drops over great distances. So, Edison's system could only deliver power a mile or two from the power source. Any further, an Edison system would result in a huge power loss over the power lines that would cause huge inefficiency. Edison was aware of the issues with his own system and hired Nikola Tesla to deal with it. Edison offered Tesla $50,000, which was a lot of money in 1889, to fix the transmission lines. After a few months, Tesla made tremendous progress, but when he asked Edison for the money, Edison replied that he was only joking, and Tesla quit. Tesla then went to Westinghouse Company, where he developed his alternating current power lines. These power lines use transformers to change voltage levels. A transformer is an inductor that has more secondary windings than primary windings to increase voltage. Transformers also allow for the opposite by having more primary windings than secondary. You can decrease the voltage this way. This allows for the voltage to be amplified before it enters the transmission lines and lowered before it enters your home. These transformers also draw some current, which allows for the use of thinner wires. The only issue with these power lines are that if they are placed too close together, they will arc and start a fire. These alternating current power lines were way more efficient and threatened Edison's direct current transmission lines. Instead of improving his product, Edison decided to try and face alternating current. To prove the dangers of alternating current, he went through a lot of different unethical experiments. According to the Smithsonian, Topsy was an elephant who was abducted from her home in Asia to perform circus acts. In 1902, she grew uncontrollable and the circus was going to have her executed. Edison saw an opportunity, and on January 4th, 1903, Edison used alternating current to electrocute Topsy, sending her to her death. Edison hoped to show the dangers of alternating current by showing how it can kill people. Topsy wasn't the only victim. Edison electrocuted a variety of animals to try to get his way. Even before the transmission lines and Nikola Tesla came in, Edison used alternating current to make the electric chair and show the effects of alternating current on the human body. Many people ask, if alternating current is so much more dangerous than direct current, why do we still use it? Mehdi answers the question by explaining how alternating current is more efficient and how direct current isn't that much safer. Yes, sending 120 volts of alternating current can kill somebody, But 120 volts of direct current can also be lethal. The main issue is the current has direct current transport a lot more current at once, and that higher current can start the power lines on fire, which is more dangerous than just alternating current, which has a very low chance of starting the power lines on fire. Another issue regarding safety is how they connect. Connecting direct current is safe and easy. All you have to do is make sure each wire has the same polarity. Alternating current, on the other hand, has a lot more requirements. Alternating current needs to have the same polarity, same voltage, same amperage, and be in phase. If one of the requirements are wrong, there will be an explosion of sparks and possibly a fire. Yes, this is an issue, but the only people who should have to worry about connecting two different alternating current sources are electrical engineers who have years of experience. Another commonly asked question is, since most of our appliances run off of direct current, wouldn't it be easier to use direct current power transmission lines? The answer is yes and no. Yes, it would be easier to just transfer it directly and not have to convert it, but it's harder to convert alternating to direct than it is to it's harder to convert direct current to alternating current than it is to convert alternating current to direct current. A bridge rectifier is a common circuit that turns alternating current into direct current. Almost all appliances have a bridge rectifier converting alternating current into direct current. Alternating current into direct current is easy, but converting direct current into alternating current isn't. A bridge rectifier is 4 diodes and a capacitor, while a direct current to alternating current converter requires voltage regulators, comparators, MOSFETs, capacitors, and a KA3525A integrated circuit.